Hello and a warm welcome from Germany. My name is Michael Dietrich and I am the CEO and co-founder of Lexolar. With the friends and partner of FXP China, we would like to invite you today for a short speech about HU revolution and how the influence of education to make this HU revolution possible. Special thanks also to the content provider of the European Union, the Hypers Network in Germany and Inside Education. Let us come now to the content what we want to talk about. Please note the following content from the big visions what will go to the knowledge what makes any bright visions possible. Part 1, some short words about hydrogen in the economy and the visions of European Union, how to integrate in the Green Deal project, and also a short information how hydrogen strategy becoming influenced in Germany, especially in our home provinces of Lexolar. Some practical facts about hydrogen and application and some questions what's the technology, find the answer. We're coming to our special area of training and education and how you can do it with Lexolar and TVET area. The Europe Green Deal is the most important future project of European Union. And it's comparable with the One Belt, One Road project of China. Most important goals are making Europe to a net zero emission continent, growing of economy without resources reduction. The budget plan is actually about 1.8 billion euros. Part of this project is also the European Clean Hydrogen Alliance. But for a better explanation, I want to give the word to the President of European Commission, President Ursula von der Leyen.
I want Europe to become the first climate-neutral continent in the world by 2050.
Most importantly is the works which are going to be done.
Appropriate support for their new obligations.
We need everyone, and no one will get left behind.
As we continue to battle the pandemic, we must also focus on our long-term challenges. This is why the Green Deal, as a growth strategy, remains our compass throughout the recovery.
We will reduce emissions by at least 55% by 2030. And today's agreement puts us on a clear path towards climate neutrality in 2050. It gives certainty to investors, to businesses, to public authorities, and to citizens. It future-proofs our union.
Coming now from the European level to the industry cluster level in Germany. One of these competence clusters is the Hypers network in the middle of Germany. Based on the historical petrochemical center of East Germany, this area is now the bridge of hydrogen movement in Germany. The most important goals are the cost reduction of green hydrogen application along the entire supply chain, establishment and expansion of secure hydrogen network on the Hypers region, clustering of local competence of small, medium enterprises, industry partners and research institutions. The Hypers Association is a comparison of large and also medium and small companies, and also famous research institutes in the area. For example, in Finland and also the Fraunhofer Research Institutes. In the second point of the presentation, I would like to talk about hydrogen in practice use. For this reason, let us think about which type of hydrogen we will talk about. Of course, this question which color have hydrogen is based on the question which technology are using for production of hydrogen. We have three different types of hydrogen production. Type number 1 is gray hydrogen. This is produced using by fossil fuels and such as natural gas. This accounts for more than 95% at the moment of hydrogen production in the world. Second part, it's blue hydrogen, and blue hydrogen is similar like green hydrogen, is a low carbon technology. This kind of hydrogen is generated by non-renewables but by nuclear technologies. And point number 3, green hydrogen, that contain low carbon and also generate from renewable energy resources, for example solar and wind technologies. This kind of technology, green hydrogen, is this kind of hydrogen what we would like use in the future to reach the goals of net zero carbon emissions in the future. Next slide, we compare hydrogen with different energy resources like natural gas, benzene or coal. One of the biggest advantages of hydrogen is the bigger capacity to store energy per kilogram. Also, when you compare with electric storages like battery or supergat, hydrogen have significant a bigger capacity of storage. Open question is how we bring hydrogen to a cost-effective level comparable with fossil fuels, including a high effective infrastructure. To give you some concrete numbers, you can see natural gas or benzene and coal can storage around 12 to 9 kilowatt per kilogram and cost 6 cents, euro cents to 16 euro cents for benzene. Compare with hydrogen, we can store much more energy per kilogram, around 33 kilowatt hour per kilogram. When we're talking about infrastructure, let us come to the one of highest priority in application for hydrogen, the transport sector. We're learning already that hydrogen have a much higher capacity to store energy. And we see in a picture that hydrogen or fuel cell solution have similar advantages like refueling technology like benzene cars. But what is the reason that at the moment the electric battery cars may be the winner in the technology competition between hydrogen and electric battery systems? This kind of question we would like answer later with a short view in the training and education systems of Lexolar. For this reason, we're coming now to part 3 of our presentations. My colleague from Development Department, Dimitri Kushnikovsky and Ronald Hübner, will give you some short and nice impression how you can educate and train hydrogen and fuel cell solution in the TVET sector, and what are the most important part in this technology. We are proudly present today the worldwide first run of the newest development of Lexolar for the customer of FXB. Please stay and waiting, my colleagues. I will thank you a lot for the participation of this seminar and I hope we can welcome you soon as a customer of FXB and Lexolar. But please wait and be online I would like to say for the moment, kind regards from Germany. My name is Michael Dietrich, and I hope we will see us soon.
Welcome, ladies and gentlemen, to this product presentation. I want to show you the main experiments of the new Hydrogen Professional 2.0 experimenting system of electrolyser. As you can see here, I've already set up some components. You see here the new double cell electrolyser. This is electrolyser with the water reservoir for the H2 and the oxygen side. For the first experiment, I want to show you that we can produce hydrogen with solar power. Inside the experimenting system you find the solar cell and the lamp, which I have already set up, and now I will connect the solar cell with the double cell electrolyser, illuminate the solar module, and now you can see that the hydrogen is already being produced. The double cell electrolyser works at a minimum of 400 milliamperes. The solar module is producing 400 milliamperes, so it takes some time for the reaction to start, but now we can see the gas bubbles of oxygen and hydrogen floating up, and this so indicates that there is hydrogen and oxygen production. So this is a method of producing green hydrogen, producing the hydrogen only with solar power, with solar radiation. And to speed things a little bit up and to investigate the electrolyzing process, I will now change my setup from the solar cell input to input via main current. As you can see here, with here a Lexolar base unit, and on the base unit we have a power module, we have a potentiometer module for regulating the resistance, and we have an AV module to measure the voltage and the current. And yeah, with this setup I can now produce the hydrogen in controlled circumstances. I will use 4.5 volts and regulate the potentiometer to produce the hydrogen much faster, and I can now check onto the voltage and the ampere and can do a new eye chart of the electrolyzing process, and can see when does the electrolysis starts and how much oxygen and how much hydrogen is really produced at which current, which voltage. To show it to the camera, you see much faster oxygen production and hydrogen production, and you see there's double the amount of hydrogen than oxygen. So this is the electrolyzing process, and for now I will continue the electrolyzing process a bit more for further experiments. Let's put this to the side. And yeah, let's continue with the fuel cell. How to set up the fuel cell stack is one of the experiments in the kit. The fuel cell stack, as you see it here, consists of 5 single cells. The fuel cell stack can be completely taken apart. And this is something very interesting for the students. To see how this really works. Can take everything apart. I can investigate how does the fuel cell stack behaves if I only have 3 or 4 or 5 cells within my stack. I can even investigate what does the single cell is capable of, so I can build and rebuild the whole setup every time. And after every rebuild of the stack, I need to check the fuel cell stack for a hydrogen leak. I can investigate this via the pressure inside my system. To control the pressure inside the system, I have this manometer, and I will now use an H2 storage module for hydrogen input. H2 storage module can store up to 10 liters of hydrogen, and yeah, as I connect it with my valve, you will hear hydrogen is stored inside the storage module. I will now seal my fuel cell with a hose and a hose clamp. So what I want to do now is I have here my fuel cell. Fuel cell is connected with my manometer and with my H2 storage module. The fuel cell is closed in the back, and now if I'm applying pressure to the fuel cell, my manometer shows me the pressure is constant inside my fuel cell system, so there's no H2 leaking, and I can go on with my experiments. If there would be a leak, the pressure would drop, and I could see that the H2 storage module gets I could feel that the H2 storage module gets colder. I have a temperature sensor here, so you can see. We can feel the H2 storage module gets colder, and with my temperature sensor I can show it to you. So this is something very important within the industry. Always be aware of hydrogen leakage, because this is obviously bad for the system. Okay, now that I have checked my system is good to go, we will check with the potentiometer and the AB module how much power we can produce with our fuel cell stack. So I will take back. So this is the electrolyser again. You see in my little presentation there was much hydrogen produced. And now I will take back my setup, rebuild it a bit. So now we want to investigate how does the power of the fuel cell work when I regulate the resistance. Now I take a new H2 storage module and check if there are no leakages in the system. Pressure is constant. I will flush the fuel cell for once, so there is now hydrogen inside the fuel cell stack, and I can now regulate and focus. And I can now regulate with my potentiometer module how the voltage and the current are. And I can build up an voltage and current chart of the fuel cell current producing process. Thank you for your attention for now. These are the main experiments of the new Lexolar Hydrogen Professional 2.0 experimenting system, and I hope you liked my small presentation.